What's up YouTube? This is Dennis Panuta for tutorialsEU. In this video, we will create a clone of the very popular casual mobile game called Roller Splat. You can find the project and all required resources in the description. That said, let's dive right in.
So we're going to build this game in roughly 1 or 2 hours, and we're going to build it in a way that it will also run on Android, because it is an Android app, it is in general a mobile app, and we of course will deploy it for Android as well. So what you're going to learn is not only to build the game in Unity and test it on your PC, but you can also run it on your Android device. And I have deployed the game over here, and you can see hopefully that the game is running, and I'm not quite that good, of course, because I'm playing it with a mirrored challenge. So I have the mirror challenge for myself. So this is what we're gonna build. So let's have a look at this real quick also on the PC. So basically you have a swipe gesture that we're gonna build. So if you want to learn how to use a swipe gesture, this video is going to be great for you, because you can then use it for your own projects, of course. So basically the goal is to color the whole ground. And once you're done with that, you go to the next level. So you can see here we have the second level, and the colors, background colors and so forth, they are randomized. So they change with every single level, and they are randomly generated. And by the way, you will also learn how to create these different levels. So you will not only see how to create one level, but two, which is going to be enough for you to learn the fundamentals of it, so that you can build this game by yourself. So you can extend the levels, and by the way, these levels are from the game, and the level design is where it actually comes in, where it's actually becoming difficult and interesting at the same time. So you can build your own cool levels, and please share your levels once you're done and share them with us. We would be very happy. Share them in the comments, and just leave a link to your project or something like that. And you can use the code for your projects. No worries, you can use that. We built the code all by ourselves. And basically you can then create a complete game. So you could go ahead and make 60 levels or 80 levels, and you can upload it to the Play Store and make some money from it. So nothing should stop you. You will learn everything here. But there are some prerequisites for this video. So you should know some C#, and you should also understand object-oriented programming to a certain degree, and also at least have seen Unity and used Unity a little bit before, because I'm not going to go into every single detail of Unity. I will explain the code, of course, so that you really understand what's going on and that you can extend the application to your liking. But of course, it's a lot easier if you know C# already. And if you don't know C# at all and you still want to build the game, please check out the other link in the description, or my complete C# Masterclass course. You can also find the link in the description. I'm also going to add a card to the free version of it, so at least to the basics part of it, in a card at the top hand corner. And by the way, this is the game that we're talking about, Roller Splat. Highly successful game. As you can see here, 17,000 ratings already. So it means that there will probably be multiple million downloads for this game. So Voodoo is making quite some money off it, and you can do so too. So you will learn how to create this little game. You can see the levels are very similar to what we have here. So this is exactly the level. So 6 and 16 are the levels that you're going to build in this video. And of course, after you've done that and you've seen how to work through it and how to build those levels, you will be able to build them with ease. So you will be able to build all of those levels. Of course, you may not just copy them and publish them on the Play Store. You will have to create your own levels, so that there is at least some difference to this Voodoo game. So just copying is not going to be enough, at least if you want to publish the game. Okay, so enough talk. I would say let's go right into the game. And by the way, if you want to learn more about C# and Unity and projects in general, then please subscribe to our channel, because we have created projects such as Helix Jump, Color Bump, a complete pixel bot program, complete C# basics course, and so forth on the channel. And we're gonna create even more cool projects. So please subscribe and leave a like if you liked the video. So enough talk. I'd say let's dive right into the project and finally get started. All right, so let's get started. First of all, we start a new project in Unity. So you need to have installed Unity before. If you have not done that, then of course you can check out the video in the card. So I'm going to add a little card here. And what you can do is, first of all, create a new project here. And you can give it a name. So we need to give it a good name. I'm going to call it Roller Splat. And I'm just going to call it 1 because I have Roller Splat already. And I'm going to store it in the Unity projects location. You can change the location, of course. And the template is going to be a 3D template. We don't need to add any asset packages or so. We just can go on and create the project directly. Now, this will take a little while, but once it's done, we can get started. All right, so there we are. Our Unity project is ready, and we go to the scenes folder, and there is our sample scene. So let's rename that straight away. Let's call that one level 1. So this is going to be our level 1, and our scene is going to be stored and saved straight away. And now we set the layout to default. It's going to be the safe bet. Of course, if you have another setup that you prefer, of course you can keep that, but in most cases default is a good choice. So things look the same as they do in my case. Next, what we're going to do is we are going to create our ground. So we have a bunch of little tiles that we want to have on our ground. And in order to add them, we can basically just go ahead and create a little quad. So let's go to 3D objects and create a quad. So I'm going to call this one ground piece prefab, and we need to change the rotation of it. So first of all, let's change the X rotation by 90 degrees. And you can already see, okay, this is going to be one little piece of our ground. Now we can go ahead and go to our assets folder and create a new folder. I'm going to call this one prefabs, because what we want to have is all of our prefabs in a specific folder. And prefabs, if you don't know it, they are basically just prefabricates, which we can then reuse very easily. So it's basically just objects that we can reuse. And we want to have multiple instances of our ground piece prefab. So we just say, okay, let's reuse this element and put it into prefabs, because that's where all of our reusable game objects will be. And of course, everything that we have in our level is a game object. So our ground piece is a game object, our lighting is a game object, and our main camera. Later on, also the walls and the ball will be a game object. Now, having a white ground is nice and all, but I would like to have different colors for it. So I would like to randomize the color of our ground. So let's go ahead and create a new folder for all of our materials, because materials are basically elements that we can use in order to change the color of elements and change the color of an object, such as our ground here. And we want to change the ground later on. So I'm going to create a new material from here, and I'm just going to call this one ground piece. For now, we can just set the smoothness to 0 and select a light blue color. So you can use this color here, B0DD8. So just go here, click on your materials and go to main maps. And now you can select the color from here next to albedo. And here in the hexadecimal, you can enter the value. So I'm just going to enter the value in here, and this will give me this light blue color. Now what we can do is we can take our ground piece and we can drag the material onto our ground piece here on the right hand side into the inspector. So click on ground piece, drag your ground piece color into your inspector here on the right, and you can see now our ground has a slightly different color. Now, by the way, if you are in a newer version, then things with prefabs have changed. So just changing it here is all good, but the problem is it didn't change it for our prefab. So if you go into your prefab and click on your ground piece prefab, you can see that it has a default material which has a grayish color. So that's where we need to drag in our ground piece once again. And now you can see that now the color will be the same for all of the different ground pieces. So the thing that we did before was just for this one little ground piece, but if you want to have it for all of the ground pieces, of which we will have multiple ones, then we need to apply the changes to our prefab itself. So you can imagine it being like the prefab is a blueprint for a game object, and the element that we have in here in our hierarchy of our scene is just one instance of that game object, okay, or of that prefab. So it's just one game object of all of the different game objects that there could be, and it's just one instance of the prefab. Now let's go ahead and create a script. So we need scripts in order to add functionality, so programmatical functionality to game objects or to our game in general. So I create a new folder called scripts in my assets folder. It's always good to keep your things tidy and keep them clean in different folders. So all of the scripts will go to the scripts folder. And in here, I create a new script, which I'm going to call ground piece. Now you could of course call it ground piece controller or something like that, but we're basically just gonna have this ground piece. Now let's go into this prefab by clicking onto this little arrow here on the right hand side. And now let's drag that ground piece script into our ground piece prefab, because that's where we want to have the script. And as you can see, as I have edited, it appears now here on the right hand side where all of the other components are. By the way, the components are all of the things that you can see here. So a transform component is the component that changes the position and the rotation of an element and its scale as well in all three directions. So the X, Y, and Z direction. Then you have a quad. In this case, this is generally the quad element, and it has a mesh filter, which basically just says how the structure of this quad is. We have a mesh renderer, which basically renders how the mesh looks like. A mesh collider, which takes care of collision. So for example, if something drops onto our ground, it should not fall through. So this is what this collider takes care of. And then we have our script where we can now add our own functionality. So we now add our own code in there, and that will influence how our ground will behave. So for example, what we wanted to do is change its color if the ball rolls over it, or when the ball rolls over it. All right, so that's basically what we want to do here. Now you can see there is another component, which is the color. So we have this little ground piece color that we have added as well. All right, now let's have a look at this script. Therefore, we need to open up Visual Studio, and you should have Visual Studio installed already. If you don't, you can install it. Just Google Visual Studio download. And here you can see this is our ground piece. Now in our ground piece script, we just need to make some minor changes, because this is a very basic script. It really just takes care of the color. It shouldn't take care of anything else, just the color and how it changes if the ball rolls over it, for example. So what we need here is a variable, and I'm going to create a public bool is colored variable, and it's going to be set to false. By the way, we make it public because we want to access this variable straight away from other scripts. And of course we could go ahead and solve this with properties, but that would go a little too far and would make our project a lot more complex. So I'm just going to keep it simple in this video. Of course, if you want to go the best practices route, you would use properties here. But generally, is colored is just going to be a Boolean, which can either be true or false. So a ground piece is either colored or it's not colored. So these are the two things that we care about. Then we need another method here, which will change the color. So we want to be able to change the color of our ground piece once we touch it. And that's why we need this public method, which we then can access from another script. So that's the idea behind leaving it public. And we use change color here, where we just set a color. So we just say, okay, if you call this method, please also pass a color so that we know which color we should set to our ground piece. And here we use something called get component. So we take the component called mesh renderer from our object, and we want to set its material.color to the color that was passed to us. And we set the variable is colored that we've just created. We're going to set that to true. So after we change the color, the is colored variable of course should be set to true. So now every single ground piece that we will create will have this script, and it will contain a variable called is colored, and it will have the capability of changing its color based on whatever color we pass it. Now, what is this mesh renderer material kind of thing? So get component, mesh render material color. Well, let's have a look. So if we look at our ground piece prefab, we can see that it has a lot of components, and that's what I was talking about earlier, right? And one of the components is called the mesh renderer, and this mesh renderer contains something called color, and it's basically the color that we assign here. So this is the color, and we can change the color of it based on whatever color we pass it. Okay, so that's basically the idea behind it. Now, to be more precise, of course, you can see that there is something called materials, and element 0 contains ground piece. So in the mesh renderer, if you open it up, you can see there is a materials property, which also contains element 0, which is our ground piece, which is basically the material that we created earlier, which was this light blue, and which we just dragged down here. All right. So basically we're just accessing this element and we're changing its color. That's it. So it's as if we would go ahead and change it in here. Okay. All right, now let's go ahead and create our level, because we have our first little ground piece, and of course we want to have multiple ground pieces. So I'm going to position my mouse and my camera in the scene so that I can now create the level. So what I'm going to do is I'm going to go to edit settings and then go to snap settings. And in here, I changed the value to 0.5, 0.5, and 0.5 for move X, move Y, and move 0, because I wanted to have this distance, because we're going to use this in a second. So it's important that you change the snap settings. So go to edit, snap settings, and then you can change it there. Because what you can now do is you have this little ground piece, and it's at position 0, 0, 0, and has a rotation of 90, 0, 0. And a scale of 1, 1, 1. It's important that you have the same values here, because otherwise things might not work out. At least it's going to be a little more complicated. So now what I want to do is I just want to move things around, and actually let me move my camera so that my blue arrow is pointing towards the top, the green, or towards forward. The green one is pointing towards the top, and the red one is pointing towards the right hand side. So now, because if you move it now, you can see it's going to change the X value, and that's what we want. So I'm going to duplicate this object by pressing Ctrl D, and then I keep Ctrl pressed and drag the red arrow towards the right. Now you can see I have a second ground piece prefab, so I have two of them now. So ground piece prefab 1 and ground piece prefab 2. Or actually, this one is without an index, and this one has an index of 1. Now I'm going to duplicate it again and again. So now you can see I have 4 ground piece prefabs already, and I want to have 7 in total. So I'm just going to mark those 3. I'm going to duplicate them, and I'm going to drag them over while keeping the Control key pressed, because this way I'm using the snap feature. Because if you don't do that, you will see that you can freely move it. But if you do use the Control key, so if you keep it pressed, you will see that things will snap. So let me zoom in a little bit so you can see it a little better. So you can see now it's snapping 0.5. So half of one of those squares that you can see here. So you have this grid that we want to be moving in, and we just move things slightly. All right, now that we have those 7 ground piece prefabs, I want to duplicate them. So I'm just copying all of them. So I have 7 of them. I duplicate them and I drag them with Control key pressed towards the top, so towards the blue hand side, and I duplicated them again. So I move it again, I duplicate, I move, duplicate, move, duplicate, move. So now we should have 1, 2, 3, 4, 5, 6. So one more, and now we should have a square. All right, so these are our ground pieces, and what we will have to do is, of course, to now create our map. So we could get rid of certain ground piece elements and we would create our map this way. But of course we need to also create the walls, so that's what we're going to do next. But before we do so, you can see we have so many different objects in here. So ground piece prefab up to 48. So we have 49 ground piece prefabs. That's 7 times 7. That's the map that we have here. And I would like to keep it tidy. So I'm just going to go ahead and create a new game object, and I put it to the top level here. And in this empty game object, which I'm going to call level, that's where I'm going to drag all of those game or these ground piece prefabs in. So if you do that, now you can close it up and you can see it's like a folder which contains all of these different game objects. And now we only have the three main components in here, or the three main game objects. You can see main camera, directional light, and level. Okay, so basically that's what I wanted to happen. And now we can go ahead and create the walls. So let's create one wall first, and it's a 3D object, which is a cube. So I just want to create this cube. You can see it already has some shade, so it creates some shade here. It's at the specific position somewhere randomly, but I want it to be at 0, 0, 0 for now. And what we also can do is we can change its position. We could put it a little bit up. So its y coordinate, we can go up to 0.5. So you can now see it's on top of our ground. At least that's the idea. So I'm going to go up. I want to move it towards the left because I don't want it to be on our ground pieces. I want it to be next to it. So what I'm going to do now is I'm going to create 4 walls. And the 4 walls are going to go all the way around. But before I do that, I duplicate one of those elements and I'm just going to drag it to the side because I want to use it in a second. Okay, so now I will scale this one up. So this one will scale the X value to, let's say 8. And now I'm using snap to move it over. Okay, and now I duplicate my piece from before. I duplicate it again. I move it over here. And now I want to also extend its size, this time in the Z coordinate. So I'm just going to say, okay, 8 again. And by the way, this one should be 9. So let's scale X to 9. You can see now it looks a little better. Okay, now I will duplicate this one, drag it to the top and scale it down to 8. So that we don't have any overlaps. We could, of course, have them. It's no problem, but I'm just going to use them without overlaps. And then the right hand side, I'm going to duplicate this one as well. And I'm going to drag it towards the left and change its Z coordinate to 7 and drag it to the right position. Always when I drag something and it's snapping, I'm always keeping my control key pressed. So if it doesn't work for you as it does here, just try to use the control key. And if that still doesn't work, then you can just try to use the same coordinates that I do. And then things should be fine as well. So now you can see we have our little level created here already, which is pretty cool. It's basically a very, very simple level, but it wouldn't work in this case because our ball would just always go to the edges. It would never go somewhere else. So what we now need to do is we need to, of course, go ahead and create the level, let's say, as it is in the game, so in the original game. So what I want to do is I want to get rid of this element here, and I want to drag my cube in there. So I'm just going to drag it in there. And now you can see this is the first one. Why am I doing this? Well, it's for simplicity. So we need to get rid of the ground element wherever we put our wall or our wall pieces, because otherwise it would, well, programmatically, it would be a lot more complex. So I'm just keeping it super simple. I want to show you the basics of how to create this game. And this is going to be a lot smoother and easier if you follow along this way instead of creating this whole complex structure that we would need in order to know, for example, when our ball goes over, for example, this ground, we color it, right? But it would never be able to go over a ground which is underneath one of those obstacles. So this here, our cube in this case, which is a wall, is an obstacle. And our ball will never be able to pass through it. So it would never be able to color this piece that is grayed out here. So if we later on check if all of our ground pieces are colored and one of the ground pieces is not colored, our game will not finish, or our level will not finish, and we will not proceed to the next level. And that's exactly where this comes into play. So we get rid of all the elements where we don't want to, well, where we can't pass, so where our obstacle is in the way, and we just put our obstacle there. And by the way, I called these things cube, and it's okay to keep it like that, but maybe it's better to call them wall piece. And I should have done that before. So now I need to rename all of my cubes here so that we have the right naming, but yeah, it's all right. It's a little additional effort. So now let's put all of those wall pieces into our level as well. So I'm just gonna drag them into the level. You can see now they are in there because I want to have everything that is within the level in that folder, at least from a, let's say, level perspective, everything that should be stiff and fixed, because these things are fixed, but our ball should be moving, so we will leave our ball externally or outside of this folder. Okay, so now let's go ahead and just create the level. So we need another corner or another obstacle in that corner. So I'm gonna drag it over there and put it to the corner. Then we need one over here. So I'm just gonna duplicate this and drag it there. And then we had two elements here. So just follow along. This is basically just using the level design of Color Splash, or Roller Splat, that's the name of the game. And that's basically what we do here. So I'm just going to also get rid of those four and create blocks down there. All right, so these wall pieces. And now, there we are. Okay, so now we have our level. As you can see, this is exactly the same design that we have in the original game. Now we of course need to also change the angle that we have. So if we look at the game currently, the angle is that we see it from the wrong direction. So now let's go to our main camera and change its values, because the values that I want to have for the main camera are as follows. So let's go to our game view so we can see the difference. So Y7, Z minus 1.5. And now what's important is the rotation, so 75%, as you can see here. And then everything else should stay the same, but we will change this one to being a solid color. For now, it's going to be this blue, but we're going to change that later on. And we change from perspective to orthographic and change the size to 10. Okay, so this is basically our level that we have here. Now, we can also move this thing a little bit, but before we do so, let's just change the build settings. So we go over to build settings, go to Android. Now we select Android as being our build platform. So we build it for Android. And I'm just pressing the switch platform button over here. And that will again take a little while until it swaps over. So I need to reload my code. And afterwards it should be done. Okay, so now once that is done, we will have it as Android. By the way, I will also click on add open scenes and I will get rid of my empty scene that I have deleted. So I just have scene / level 1 in here, which is basically the scene here, level 1, or the scene here, this one here. So this is basically the scene in which we are. You can use scenes as levels. That's an easy way, but of course you can also have multiple levels in the same scene and so forth, but that would create a lot of more programmatical challenges, let's say. So now in game mode, what I want to change is here, low resolution aspect ratio. I want to deactivate that. And then I go to 18:9 portrait mode and I change the scale. So now you can see that as it seems, our level is not positioned at the right spot. And now what we of course can do is we can move our level a little bit to the side. So I'm just gonna use -3, for example, for the X coordinate, and you can see now it goes over to the left. And now we can also change the coordinate of our Y position. As you can see, now we can go up or we could go down. So I'm gonna use something like -7. That should be centered now. Okay, so just play around and you can already see what the advantage is of also having this in one folder. So all of our pieces in one folder, because now you can move everything at once and you don't have to move every single piece manually, because you can just move the whole level over if it's not at the right spot. Now you can see that the shadows are quite intense here, quite strong. We can change the directional lighting of our light here. So the position should be at 0, 3, 0, but then the rotation at 75 and here 145. So this will create this little shadow from the top, and I think this is a little nicer. Now, by the way, of course, we can go ahead and take one of those wall pieces, and thereby it's the best if we take one of the small pieces. So for example, this one, and we create a prefab from it. All right, so now we have this wall piece prefab. So if we ever should decide to create other wall pieces, we will have stored them as prefabs here and we can use them.
So far, you have learned how to design the first level of the game. Now we step over to the coding section. But before we do, I want to show you what we have created to make you an awesome C# developer and advanced Unity programmer. In the masterclass, you will not only learn the basics of C#, but also many advanced techniques. However, the most important point for you are for sure the games we will develop together. There we have Pong, Fruit Ninja, Minesweeper, Flappy Dunk, and many more. Get the course for just $9.99. Just follow this link and click on Buy Now. Now you might wonder, how does this masterclass differ to my YouTube content? Well, you get 5-star support, exercises, bit chunk and in-depth information about every important topic, and of course, loads of example projects with best practices. And you get invited to an elite Discord channel. So if you are serious about learning C# and Unity, then don't waste any more time. Enroll now and join the club.
While we're in here, we can also go to our main camera and then change the background color to something like ADE 54B. That's going to be the one that I'm using. So if you go to game mode, you can see that we have this greenish color here, this green yellow. And we will adjust that later on, of course, where we'll have this beautiful gradient. So we're going to use gradients later on, and we're going to use shaders and stuff. So quite some advanced stuff, but we're still going to keep it simple. That's important. In this video, I want to keep it simple. Okay, so now we have our level, which is pretty cool. You can see that it just took us 10 minutes or so, or 15 to create this level, or maybe 20, depending on what you want to count as part of the level creation. And now we can go to our script. So we have our ground piece, which is almost done, but we need other scripts here as well. So for example, we need to have our ball, which also contains the script for the ball and so forth. And I think maybe it's best if we just create the ball real quick. So in the hierarchy, right click, 3D object, and then here you can go ahead and create a sphere. And I'm just going to call this one ball, because this is basically going to be the ball of our game. And now our ball should have another position. So currently you cannot see it, but there we are. So now you see our ball, it's at 0, 0, 0. And as it seems, our level is at -10. So, or actually at -7 here for the Y value. So let me put that to 0. That's something that I didn't do correctly before. All right. But what we can do now is we can reposition our ball. So currently it's at 0, 0, 0, and I will move it over to -3, 0, 0, because our level starts at -3, and that's exactly where our ball should start. Now you can already see that it's just at the edge, and it's slightly above our level. So let me see again. Our ground pieces are, well, all of our ground pieces are at -1. So what we can now do is we can go ahead and set our level to 1. And we need to move our ball up by 0.5. So we set the Y coordinate to 0.5. Okay, now you can see that our ball is on top of the ground and just at the wall. Now we can change its scale a little bit. So let's put it to 99%. So 0.99 in all directions. So now it will just about not touch the walls, and it will just about not touch the ground, but of course it will be on top of the ground. So the idea is that our ball should not touch multiple ground tiles at once, or ground pieces, because every single ground tile will be colored as soon as the ball touches them, and if the ball is a little bit too big, it could touch multiple tiles at once, and multiple tiles would be colored at once, and we don't want that. So that's why we changed the scale down to 99% for it. All right, now in the scripts folder, we are going to create a new script, and the script that we're going to create is the game manager, and this is a very important script because it basically takes care of the game state. For example, is the game won, then it should go to the next level, or what's the score, then it will display the score, and so on. So game manager is going to be the script, and we can now open up the game manager, because in there we need to add some minor stuff. So for example, first of all, we want to make sure that there is only one instance of our game manager. What that means is that we don't want to have multiple game manager objects in our game. So at all time, there should always be one game manager, and it should always survive swaps from one scene to another. Because usually if we move over, let's say we have the scene here, level 1, if we create another scene, so if we create scene 2, which would be level 2, for example, then our game manager should not be recreated, or it should not be another instance of a game manager, but we always want to have the one game manager that survives this swap from one level to another. Because in the level, as you can see, we have everything in here. We have our main camera, we have our light, we have our whole ground and walls and obstacles, and we have our ball and so forth. But what we really want to have is also a game manager. So I'm just going to create a game manager in here. So this one will be game manager, and I'm going to assign this game manager script to it. So we have in the scripts folder, we have this game manager script. I'm just going to drag it into the game manager. You can see that now it's available here. You can change the game manager's position to 0, 0, 0, even though it doesn't really matter. But now our game manager is also part of that level 1, as you can see. But what I want to happen is that it will also be the same game manager object or instance in level 2, level 3, level 4, and so forth. So it will never be, or there will never be multiple game managers at once. This sounds a little complicated, but basically what we want is to only have one game manager. And how we can achieve that is by making a static game manager object, which is called singleton. So you will often also find the name game manager, but I'm just calling it singleton because that's exactly the concept of it. That's what it is. A singleton is an object that only exists once and also is, well, in our case, is always active, so our game manager. So once we start our game, what we want to happen is we want to set up our level. And in order to set up our level, we need to create an array of our ground pieces. So private ground piece, and I want to create an array, and I'm going to call this one all ground pieces. So what that is a collection of ground piece objects. So you can, as you can see, a ground piece is this little piece here and this one. So all of these tiles are ground pieces. At least that's how we call them. Okay. So ground piece 1, 2, and so forth. All of them are ground pieces. And I want to create one array which contains all of the ground pieces that we have in the game, so that we, for example, know that if all of them are colored, our level is done and we can go to the next level. So that's the idea behind our whole array that we create there. So we go back to our game manager. Now we create an array with all ground pieces, and at the start we want to find all of the ground pieces. And I'm just going to create an method here, which I'm gonna make private because it should only be accessible by the game manager, and it will set up new levels. So this is going to be the name of it. And here I'm just going to set all ground pieces to find object of type, and here of the type ground piece. So that's something that is actually pretty cool, and this is available in, and this option or this method or approach is pretty cool because it's available in Unity and it's not available in most other languages. So you can see here it's found objects multiples. So it's not a single one, it's an array, so it contains multiple, it can contain multiple objects. So it just says find objects of type ground piece. So what this does is it just says, okay, I'm going to check in the whole scene if there is an object which is of type ground piece. So it will find all of the tiles, all of the ground tiles that we have in our game or in our level, in our scene. So in the start method, I just want to call this method. So the start method is a method which will be called as soon as the game manager is created. So as soon as our scene is loaded and our game manager is created. Why will it be created? Well, because we have this game manager object which contains this game manager script. So it basically will just call this script that we have just created, and it will run the start method straight from the start, so that it will basically then just go and check for all of the tiles that we have. All right, so now we can go ahead and create another script, and this script will take care of our ball. Because so far we have created the map, we have created the game manager, it's all cool. Now we want to finally have some movement because our ball is just laying there. It doesn't do anything. We cannot move it. And that's what we want to change now. So I'm going to create a script called ball controller. And this is just a good name for something that will control an object. Ball controller will control the ball. So that's the idea behind this. So in the ball controller, we will have most of our code actually, because in here, we will take care of the mechanism of coloring, of moving, or of swiping. So we will swipe and then move our ball. And that is basically it. But this contains a lot of code. So there's a lot of things going on here. So I'm going to get rid of those two methods because as soon as I need them, I will just implement them. But for now, we need to have a rigid body. So what is a rigid body? Well, it's a component which takes care of movement. So if you want to have movement for an object, you need to have a rigid body. So in this case, I'm just saying, okay, our ball should have a rigid body, and please give me that rigid body that I need. Okay, and then we have public float speed, because we can also set the speed of our ball and make it public so that we can change it in our Unity editor. So we can adjust our speed as we want. Let's have a quick look at what I mean by this. So I'm going to save the script, Control S, save the script, go to the ball controller, and I'm going to have my ball here. And you can see here on the right hand side, it has a lot of components, right? So it has the transform component, like every object. So every game object has a transform component. Then it has a mesh filter. In this case, it's a sphere mesh filter. So it's very similar to our ground piece prefab. You could see that it had a quad mesh filter. So now our ball has the same thing, and it has a mesh renderer, it has a collider. This time it's not a collider that we had, for example, for our wall pieces, where it was a box collider, which took care of collision for that whole box. So it pretty much just stops other elements that have, or other game objects which have a collider. It stops them from moving through them. Okay, so that's basically the idea. And we have the same thing for our ball. So it has a sphere collider in this case because it doesn't want to look like or move like a block. It wants to move like a ball. So that's basically the idea here. And what we need to change is we need to add another component to our ball. As I said, if you want something to move, you need to add a rigid body to it. So we need to go to add component here on the right hand side, and then we just select rigid body. And from here, you can see the rigid body component has been added, and basically it adds physics to our ball. And by physics, I mean things such as a mass, such as gravity, so you can turn on or turn off gravity, such as constraints, so you can freeze rotation and position of the movement of a ball, because now our ball can move in the game. We haven't implemented the functionality that we make it move yet, but it can basically move. So what we can now do is we can freeze its rotation, for example, so that it doesn't turn around, because it doesn't need to turn. It just is a ball which doesn't have any specific sides or something like that. So it's not like one side is red, the other one blue or something. It's just going to be a plain ball. And so we can deactivate all of those rotations. Another thing that we can deactivate, by the way, it's under constraints, is the Y point. So just check Y, because you don't want the ball to suddenly jump off your platform. You always want to for the ball to stay on the same Y level, so on the same height pretty much. So you don't want the ball to go up and jump around and stuff like that. Those things can actually happen. So really make sure that your freeze position for Y is ticked. Not for X and Z, because we still want the ball to be able to move to the right and towards the front, so forward. Okay, so these are the directions we want to keep, but we don't want it to go up. So the green arrow should never be going up, or the ball should never go towards the green arrow. Now our ball has a rigid body, but it also needs this ball controller script. So let's drag that in there. You will see, okay, now we have this ball controller. And now I finally come back to this point where I said it would be public, okay? Because now you can see speed is available here, and you can adjust speed here. So we set speed to 15, and we have created a variable which is a rigid body, but you can see that there is none in there. So we need to drag the rigid body that we just added to the ball. We need to drag it in there. So just drag the rigid body over to this element where we had this name RB. Okay, so this is our rigid body now, and now our ball will be able to be moved by our code, and we were going to implement that in a minute. So for now, let's just add the fixed update method. So private fixed update, and in here we just say RB, which is our rigid body, so the thing that makes our ball move, dot velocity, which is the speed of the ball, and then we set the velocity to our speed. And by the way, we multiply that with vector 2 dot forward, or actually vector 3 dot forward. All right, so now our ball should move forward once we start the game. So let's save the script. We're gonna, of course, adjust this code so that it's not just constantly forward, but it's actually going to move the way we want. So now let's start the game. And we saw that the ball moved up. Okay, so let me change the speed. Let's change it to 1. And then you will see that the ball moves a lot slower, but it's still gonna move. So you can see now the ball moves forward. And it only knows one direction, so it's always going to move forward. So now it's still trying to move forward even though it cannot. Okay. So now let's go back to our code and extend the functionality so that we can swipe it to all directions. And that will be quite some code that we need there. But it's pretty cool code that you can reuse for other projects. So back in our ball controller, what we need to do is we need to have a variable which knows if our ball is traveling or moving or not. And I'm just call it is traveling. You could call it is moving or whatever, but it's basically that we want to set this variable to true as long as the ball is moving. Why is that? Because as long as the ball is moving towards a direction, we don't want to be able to swipe it to another direction because we could then cheat. So we always only want to be able to move the ball once it's arrived at a wall. That's why we need this is traveling variable. And then we have another private, this time a vector 3 variable, which will be the travel direction. So travel direction, because I want to know whether it's going towards the top, towards the right, left, and so forth. Of course, it can only move towards front, left, and right, and bottom. So it should never go up and down. It should only go towards 4 directions, okay? So then we have another vector 3 variable. So I'm just going to call this one next collision position. So this is just going to be the direction of where the next collision should be. And then we need some more variables. So we need quite some variables here, okay? But it's important that we have those because we will need them, for example, for swiping our ball and stuff. So I'm going to create a new public int min swipe recognition. And this one, I'm going to set it to 500, maybe 1000 is better. But this value basically will be used to just say from which swipe distance should the swipe be recognized as an actual swipe. So let's go back to Unity real quick. So let's say I only swipe my mouse, maybe here is better. I only swipe my mouse like this. Is it going to be enough to be recognized as a move? Or should my mouse go like that? So should it go like at least one tile, or should it go at least 2 tiles? Or should it even go 3 tiles in one direction before it is recognized as a move? Because you don't want the ball to move if you just touch the screen just a little bit and it already moves. So that's what this minimum direction is, where you say, okay, you should move your finger at least a certain amount before the movement or the swipe is recognized as a move. Okay, so this is what this min swipe recognition variable should be used for later on. And then we need private vector2. So now vector2 is a 2D vector, by the way. Vector3 is a 3D vector. So a 3-dimensional vector which has left, right, up and down, and forward and backward. And a vector2 only has left, right, forward, and backward. Okay, so that's what this vector2 is. Why only vector2? Well, because our screen is not 3-dimensional. It's just a 2D screen, so our swipes can only be recognized as 2D swipes. So that's basically why a 2D vector is totally fine here. And I'm going to call this one swipe position last frame. And I need 2 more of those, so I'm just going to copy that. This one will be swipe position current frame, and this one will be current swipe. So quite some setup here, okay, but no worries, follow along. We are going to use this real quick or very soon, and then you can really, as I said, just reuse that for your own projects. And by the way, if you feel like what you're seeing here is adding value and you like it, then please subscribe to the channel. You really help me out. I'm really appreciative if you do so. Okay, so subscribe to the channel, leave a like to this video, and of course check out all of my other videos whenever you can. If you like my voice, you can also just leave it in the background, just listen to it, stuff like that. No, just kidding. All right, let's go on. And then the next thing is in our fixed update method, instead of always moving our ball forward, I want to move it to a certain direction. And I only want to move it if the ball is traveling. So if this is traveling Boolean that we have created earlier, only if that one is true, I want to move the ball. And I want to move it not with the vector 3 forward, but with the travel direction. So this variable that we created here. Okay, we will set it in a minute. We will set it based on the swipe, of course, and that's what we're gonna do in our fixed update method. All right, next, what we need to do is we need to have the next collision position, and we want to check whether it's not vector, or we want to make sure that it's not vector 3.0. And here we basically want to just make sure that our ball has not reached the direct or the destination yet. And by destination, if we go back to our game, by destination I mean, for example, the ball starts moving and it's moving up to this wall here. It should not go further than this wall, but as soon as it touches the wall, it has reached its direction. And only at that point, it should be able to be swiped again or moved again. So we can only change the direction of the ball once it reached its goal or its destination. So that's what we have the destination variable for, which we're going to use here. So if vector3.distance transform.position comma next collision position is less than 1. So a lot of code, a lot of complex code. What does it mean? Well, we're just saying, okay, is the 3D distance, so the distance in a 3-dimensional room of the position of the ball, so transform.position gives you always the position of the object that contains the script. So we see the script that we're looking at is the ball controller.cs, which means that the ball's position is the one that we're looking at. So what is transform position? Well, let's go back to Unity, because here, if we check our ball out, and this is boring for for pros, I know, but for beginners, I think this is important. So we have this transform component here, and it has a thing called position. And this is a 3D vector or a 3D position pretty much. So it's a X position, a Y, and a Z position. So I'm just saying, okay, give me the transform position of the ball in my script and compare it to next collision position. So next collision position will be the position of the next wall that our ball is moving towards. So if that is less than 1, then we want to run some code. And the code that I want to run is, I want to say is traveling is going to be false, because at that point our ball should stop moving. And the next thing is travel direction should be set to vector 3.0. So this means that it shouldn't move anymore. So travel direction is the multiplication or the multiplier, which says in which direction our ball should move. So the direction where our ball, or the speed at direction in which our ball is moving, is a combination of the speed that we have set, which is the variable here, which we set to 15, and the travel direction, which is the vector 3, so a 3-dimensional arrow which shows towards a certain direction that we have here. So we will set the travel direction later on, but here we set it as well to 0, which means we don't want the ball to move. So that's basically what we do here. And at the same time, we also need to make sure that our next collision position is also set to vector 3.0, because, well, we don't have a new next position, okay? We don't have a new next position where the ball should go. It's going to be set later on by the swipe. Next up, we have our swipe mechanism. But the thing is, I only want to run any swipe mechanism code if our ball is not traveling. So if the ball is traveling, I just want to return. So I'm just gonna say, okay, if the ball is currently traveling, then get out of this fixed update method and don't do any other code that is within the fixed update method underneath, so which is lower. So which is basically the code that we're gonna add now, which is our swipe mechanism. So I'm just gonna say if input dot get mouse button 0, which is touching the screen or clicking on the mouse. So that's the get mouse button 0. If that happens, so if somebody presses on the screen with his finger or with the mouse, and that's a cool thing, Unity doesn't care. It's the same thing. It just says get mouse button. It's, well, it works for the touch screen as it works for the PC. That's a cool thing. Then we first of all want to know where our mouse is right now, or where the finger is right now. So we want to know the swipe at the swipe position at the current frame, and we get that by doing the following. You just say input dot get mouse button, or it's mouse position dot x and input mouse position dot y. So we want to have the x and y coordinates of where our finger or our mouse currently is. And then we check and compare it to the last frame. So the swipe position of the last frame, and we check if that was not vector to 0. So it was not, if it was not at a 0 point. So let's say we have our game or screen here. So in here, the 0 point would be here at the top left corner. So here where my mouse currently is, top left corner, that's the 0, 0 position. So just wants to make sure that it's not there, because that's the default position of the mouse swipe. So usually somebody doesn't swipe from the very top left, but he swipes somewhere on the screen. So we're just basically checking, is it not at the top left where the default value would be? Because if that's the case, then, well, it's actually a swipe of the user. So in here, we can go ahead and set the current swipe to be the swipe pose current frame minus the swipe pose last frame. So this is just basically saying, okay, in comparison to the last frame And by frame, I mean frames per second. So we're talking about, let's say a game is running at 30 frames per second. And in the last frame, your finger was at the certain position, and now it's at a different position. At the 30 frames per second, one frame takes 33.3 milliseconds. Okay, so every 33.3 milliseconds, it's going to check where is your finger right now in comparison to where it was 33.3 seconds ago. And that's going to be basically this current swipe, which is a vector2, which is a distance on the screen. So it just says, okay, let's say your finger traveled in this time of 33 milliseconds, it traveled, let's say 5 millimeters or 10 millimeters, like 1 centimeter, for example. Then that will be stored in this variable called current swipe. Okay, now we can go ahead and say if current swipe dot square root magnitude is lower than min swipe recognition. So this is a little complicated, this whole square root magnitude thing, but basically it returns the squared length of this vector. It's basically just going to create a square root value from our current swipe, which was the distance that our finger traveled or our mouse traveled, and it's going to compare it to minimum swipe recognition, because our minimum swipe recognition, let's have a look, is 500. And let's say 500 would be 5 millimeters. Okay, so if your finger only traveled 5 millimeters in that time or during that time, then the swipe should be ignored, because it didn't go fast or far enough, and we're just gonna interpret it as if the user didn't want to swipe. He just accidentally had his finger on his screen or something like that. So we just said, okay, if this value is below 500, then please do nothing. So we just say return here. So basically, we don't want to do anything with the swipe if it's just that little bit of a movement. And I just said 500 would be 5 millimeters. It's not really the case. This is just to make the point clear. It probably is a little more or less. I don't know. I don't know exactly how many millimeters it is, but it basically is a small value, and you can play around with the value. If you see, okay, your swipe is not being registered, then maybe you want to reduce the value. If you see swipes are registered way too quickly, then you would want to increase the value to, let's say, 1000 or 700 or something like that. So that's basically what you can then test. All right, so now what we can do, now that we know that the current swipe is big enough or the user swiped far enough, what we need to do is to normalize it. So if we normalize a value, what we just do is we say we want to get the direction, not the distance. So I don't want to have the whole distance that the user swiped here, but only in which direction did it go. So did it go towards the top? Did it go towards the bottom? Did it go towards the right or the left? So that's basically what I want to have, and that's where I get by using this normalize method. And now if it goes up or down, so it was an up or down swipe, I want to do it the following way. So I'm going to say current swipe.x is greater than minus 0.5 f, because we're talking about the float here. So I'm adding the f here. Then the alternative is, or on top of that, it should be less than 0.5. So it's between minus 0.5 and plus 0.5. And this one here is the x value. Okay, so you were just saying, is it in the top quadrant? Pretty much. If that's the case, then set the destination. And by the way, that's a method that we need to write. So if that's the case, go up. Okay, and now we do the same thing for, or go up / down. And here go left / right, because we hereby look at the y value. So let's change here. As I said, so here in go left and right, it's important that we change it to y, because now we're looking at the y values. So if it's y, then we want to move our ball towards the left or right. If we change the x value, or if the x value is bigger than or lower than, so in a certain area, we want to move it towards that direction, okay? So towards the top or bottom, or go up and or down. So now what we need here is a new method. So I'm just going to create a new method here real quick, which I'm gonna call set destination. So private void set destination. And sorry that we are writing so much code here, guys, but it's basically the code that we need in order to use swiping. Okay, so I would love it to make it shorter, but that's the tools that we have available here. So I'm just gonna do it as quickly as possible. Okay, so we set the destination vector3, and we say, okay, we want to have the direction to which the ball should be moving. And now what we do here is we set our travel direction to be the direction that was passed to the method. So once set destination is called, we want to change the travel direction, and that's the direction our ball should move to that direction. Okay, now comes something that is a little more advanced, but what we're going to use here is something called raycast hit. So this raycast hit object, which we're gonna create, I'm gonna call it hit. It basically checks which object will it collide with. So if we look at our Unity code again, so we have our ball here, and actually maybe it's better this way. So let's say somebody swipes, this is usually the map, somebody swipes towards the top. Then our ball will move in that direction, right? At the same time, it will also cast a beam, so a ray cast, it will beam towards the front. And then it will look, is something there? And in this case, it's obvious, yes, there is. It's this wall here. So this wall, that wall here will be in the way. So this beam will show as, or show in the direction of this blue arrow that we have here. So we'll show this way and we'll check, is something there? And it will actually see, okay, this is going to be, so this wall here will be the next hit point that I have. And we talked about hit point before, where we actually had it in the code. So let's go here and set it. So what I need here is physics dot, and here I need to be precise. So physics dot raycast dot, or actually transform dot position. So the position of the ball. And now look into the direction, and that's the direction that we get once this method is called. And now give us a result, the hit. So did you hit something or not? And now let's say, how far do we want to look? So we're just saying, okay, I want to cast 100 distances away. And if I find something on the way, then, well, then I will give an out. Okay, so I'm gonna give, or hit will be something. So we can use hit. It will, the output will be stored in our hit variable. Okay, so that's better set. So what we basically then want to do is we want to set our next collision position as being hit.point. So what does that mean? Well, as I just said, it's the direction where we're hitting something. So if we hit the wall, the point where we hit the wall, that's going to be the hit point. And this hit point, we want to store it in our next collision position because we will need that in our code, and we needed it in here. So we checked, is the next hit position not 0? So are we not hitting nothing? If we do hit something, then please say, okay, stop now, or stop moving now. That's it. So we could, of course, and now if you know Unity well already, you could say, hey, why are we not using physics? So why are we not just saying, okay, there is a wall, so the ball will automatically stop because there are colliders here. So we have a sphere collider, we have a box collider. Once they touch each other, they will not be able to pass each other. Okay, yes, that would work, but the problem is that unfortunately it doesn't always work. So in some cases, it actually creates bugs. And that's why we do it programmatically. So what we do there is a little workaround in order to make sure that it actually always works and it doesn't crash. So this is just a programmatical way of making sure that things work. All right. And by the way, while we're here, and this is important because I didn't do it before, as I forgot, I'm sorry, but what we need to do here is we need to set collision detection to continuous. What that will do is it will look at collision in more depth, or it will be a lot more precise, let's say. Okay, so now you might say, hey, we're not using collision. You just said that. Well, I still like to use continuous as the collision detection for my main character, because if you have 1,000 objects and you set continuous, then that's super resource hungry. You shouldn't do that. But if you have one very important object and that is your main character and you want the collisions to be correct, then you set it to continuous. All the other ones can keep discrete. This is less resource hungry or resource taking. But the main character, in this case, our ball is our main character, should have a collision detection of continuous. Because what otherwise can happen is that your ball moves, unfortunately, or by accident, through collisions. So it could just move through a wall or something like that. And you don't want that to happen. So that's why continuous is a good choice for your main character. Just a little side note, and just wanted to show you. And if something is buggy, then just set that and try if it solves the problem. Okay, now going back to our set destination, next collision position, we set that, and we now can go ahead and just say, hey, if we set this destination, which means our ball will move towards a certain direction, what we then can do is we can just say, okay, our ball is traveling. So we just say is traveling is equal to true. Okay, now this method, we prepared it and we're going to use it now. Because we said go up and go left, right, we need to do something in there. Well, what we need to do here is to call the set destination method. And here we just set the value to current swipe dot y, and we check is it less than 0. If that's the case, then set the vector 3 towards forward. If it's not the case, then set vector 3 towards backward. Okay, what does that mean? Well, we're using an advanced if statement here. If you've never seen advanced if statements, then of course check out a video on that. I personally don't have one yet, I think. But basically what we're doing here is we say before the question mark, we have an if statement like we do here. So we also use if here where we say current swipe is greater than so and so forth. We do the same thing here. So we say if current swipe dot y is greater 0. If that's the case, then go ahead and run vector 3 forward. Else run vector 3 backward, or use vector 3 backward. And this is, in this case, we're just passing something to our set destination. So we could have created an if else statement here, but that would be a lot more code. And this is also a little side learning for you. So you learn something else here as well. Now the thing is, we can use the same code here as well. So also set destination for our current swipe y, only that we now turn it around. So we can just say current swipe dot x greater 0. If that's the case, then use vector 3 dot right. And if it's not the case, then use vector 3 dot left. That's it. So that's the magic. So now there is one more thing left, or actually there are two more things left. First of all, we need to set our swipe position last frame to our swipe position current frame. What does that mean? Well, we have a current position for our finger in that current frame. And because we have used it already and we're done with the processing of it, we can say that in the next iteration or in the next run of our fixed update method, which by the way is doing all of that stuff, fixed update method is, or this method is called 30 times per second, or 60 times. So it's a specific fixed amount of times that this is called, so that the performance is always the same on all devices. It's basically just saying, okay, swipe position last frame, and the next frame will be our last frame. So here we're saying swipe position current frame is in the next frame going to be our last frame, because in the next frame we are in a new frame, and this frame is going to be the last frame. Okay, I hope that helped. So then the only thing we need to add inside of our fixed update method, and by the way, we're still inside of our fixed update method. So let me close this down a little bit so you can see it a little better. So in here, so we, by the way, I used this minus in order to reduce the size of all of this code. So basically we just still in this fixed update method, and in here I just need one more if statement, input dot get mouse button up. So if we release the screen, so that's what we're doing here, we just say, okay, mouse button up means we release the screen, so we're not touching the screen anymore, or we're not clicking our mouse anymore. Okay, so this is what get mouse button up does. This is get mouse button. Usually you could of course also use get mouse button down. It's exactly the same thing, but get mouse button is easier to write. All right, so then we have swipe pose last frame. So if we release our mouse, we can set our swipe position last frame to being vector 2.0. So here we're setting it back to 0, and we set our current swipe also back to vector 2.0. So what we're basically just saying is our whole touch element or touch is done. So the whole touch thingy that we touch the screen. Okay, so we have a lot of swiping done here. You can see this is a lot of code, but basically this part here and everything going from here down to there is all our swipe part. Actually, the set destination is more or less also a swipe part, but it's not really the swipe code. But what you can do is you can use this swipe code for your own projects if you have some other projects that you want to use. Okay, by the way, you will also find the whole code in the description, so you can download it and use it for your own projects. Okay, a lot of stuff. I hope after all of this code I didn't lose you, but now we can finally go back and test our code. So now let's run the game, and my ball is at the wrong position, but anyways, as you can see now I changed the speed to 1. Now let's actually stop the game. Let's set the speed to 15, and I'm going to reposition my ball because I want it to be at the bottom here. So this is going to be Z0. Okay, so now let's test it again, and we can see we can now move our ball. And as you can see, while the ball is moving, it ignores all other movements. So it's only able to change its direction or its movement when it has touched a other wall. So when it found its destination. So this is where all of the magic comes into play. So this is really where we had all of this additional stuff that we needed. So that's why we needed to have this is traveling. That's why we said return. So get out of this whole thing. Ignore any additional input if you are already traveling. If you're not traveling, yeah, then go ahead, use this import. So get the user input, meaning get the swipe of the user. Okay, so we're almost done. There are just some few things left. For example, we need to color our map. Then we need to add the canvas where we see, for example, the level that we're currently at. And then we need to create another level. And this is hopefully going to be done in less than half an hour or 20 minutes even. So let's change the color first. We want to change the color, and therefore I need to create a few new variables, or actually one new variable in our ball controller. So private color, and I'm going to call this one solve color, because this one is the color that is going to be set once we solved an a field, or once we ran over a field. So we need the start method this time. So private void start. And in here, we need to set the solve color to a random color. So I want to have a random color set, and I'm going to use HSV, which is going to basically create a random color from HSV and alpha ranges. So it's going to take the hue value. If you want to learn more about HSV, you can check out the documentation. But basically what we're just saying is just set a value or set a color, and I want to have a light color. That's why I'm adding something like 0.5F in here, and the hue maximum should be 1. So by doing this, I basically just only take pretty light colors for the solve color. All right. And then I will get the component mesh renderer of our material color. So here, material.color equals solve color. So I'm just setting a different color to our object there. Now what we can do is we can also change the color of our ground. So let's do that in here. And I do that in the fixed update method after this if is traveling and before this is this if next collision position. I'm just putting it in here. And I need a collider, and in particular a collider array, because there are multiple colliders that we want to use, and I'm going to use hit colliders, or I'm going to call them hit colliders, and here we use physics dot overlaps sphere. What that allows us to do is to create a little overlap sphere, which will be just below or just here at our ball. So it will create a little sphere here at the bottom, and it will check if it touches something. So the idea is that the sphere is going to touch the ground tile, and by that it will trigger the change color method, which will then change the color of the tile itself. So we want to change the ground, right? So that's what we're basically doing here. So let's go back, and I'm just saying overlap sphere. There it needs to have the position, and I'm just going to say transform position minus vector 3 dot up divided by 2. And here I'm just saying, okay, make this 0.5F big. So it should be a very small sphere. I don't need to have a big sphere. I don't want to touch anything else except the ground. So that's what I'm just saying. Just use the position of the ball minus go down. So basically we just say go down half of the ball, and then just make it 5% the size of what the ball currently is. Not particularly, but in this case it will be 5% of the ball's size. Okay, so we're just creating a very small ball underneath the ball or underneath the sphere, and now each time that it hits something, and it can hit multiple things, that's why we need a collider array instead of just one collider. That's why we do that pretty much here. So I'm just going to set I to 0, and I'm going to run a while loop. So I'm just saying while I is less than hit colliders dot length. Please go ahead and use the ground piece, and I'm going to call this ground piece ground, and take the hit colliders at position I and take its transform dot get component. So get its component called ground piece. And ground piece was also the name of the material. So here we're just saying if the collider was a collider with ground piece, so if we collided with a ground piece, so with one of those ground tiles, then store that in the ground variable or in this ground object that we created here. And then what we can do is, if the ground actually is true, so if something is in there, so which means that we actually hit a ground and we didn't hit anything else, and if the ground is colored is not true, this is why we have this additional exclamation mark here. So we're just saying if the ground is not colored and you touch the ground, then please change the color of that ground. So here we're just saying ground dot change color and change it to the soft color. And the soft color is the color that we created here in the start method. So we're just creating a random color each time that we start the game. And this means that we're going to change the color of the ground each time that we run the game. It will be a different color pretty much. Okay, so that should be it. The only thing we need to add is an I++ in here. So I++ in our while loop, otherwise we have an endless loop or an infinite loop, and we don't want that. Okay, so I hope this is enough. This should be enough. So let's go back to our project and see if we already can change the colors. And there we are. So you can see now we're changing the colors. And let's run it again to see if we get a different color this time. Yep, we do get a different color. All right. So you can see now we can color our ground. And this is amazing. This is actually pretty cool. And it's always a different color for our ball and for our ground. Now you can also see why it makes sense to do the following lines. So here we're saying solve color and get component mesh renderer material color solve color. So here we are actually setting the color of our ball. So by the way, here we're creating the random color. And here we're setting this random color to our ball. And here in our fixed update method, this is where we're actually passing that color to our ground piece, where we had this change color method, which expected a color object. And then it says, okay, I'm going to change the color of myself, which means of the ground piece that we have touched. And which element is that? Well, that's the one that we hit a collider with, or we had a hit collider with. So where this little overlap sphere that we created, which is underneath the ball, touches the ground, and then that ground will change its color. Bam, done. All right, so that's perfect. Now we can do some more things. For example, we need to add a little text in here. Then we maybe want to also change the position of the level. So I personally don't like where the level is. And I'm actually going to change it to something like -12. I think -12 is good. But then we also need to move the ball a little bit. -2 should be good now as well. Alternatively, of course, we also could have moved our camera a little bit. So there are multiple different options in Unity, as always.
All right, now you have learned the core mechanics of the game. And before we get to creating level 2 and the level swap algorithm, I just wanted to quickly remind you about our 30+ hour-long C# masterclass, which is the perfect way for you to become a real C# and Unity developer. In the masterclass, you will not only learn the basics of C#, but also many advanced techniques. However, the most important point for you are for sure the games we will develop together. There we have Pong, Fruit Ninja, Minesweeper, Flappy Dunk, and many more. Get the course for just $9.99. Just follow this link and click on Buy Now. Now you might wonder, how does this masterclass differ to my YouTube content? Well, you get 5-star support, exercises, bit chunk and in-depth information about every important topic, and of course, loads of example projects with best practices. And you get invited to an elite Discord channel. So if you are serious about learning C# and Unity, then don't waste any more time. Enroll now and join the club. Alright, I'm looking forward to having you in the course. And now let's get back to finishing Roller Splat.
Okay, so now that we have that out of the way, let's go ahead and add our canvas to the game. So let's do that real quick. Go to UI, text, and now you have a text in there. And now in Canvas, what I want to have is UI scale mode should be set to scale with screen size. And here we set values of 640 times 960. And then we go to our text itself. And here, press on this button here under Rect Transform or the anchor. You can set the anchor to top center. And then we set the text to level 1. Now, of course, we need to also change the font size. I'm going to set that to 100. I'm going to change the font style to bold. I'm going to change paragraph to alignment center in both directions. And then I overflow vertically and horizontally. So now you can see this is where my level 1 is. And I needed to make those little changes. So basically, we're just saying, okay, position the text centered. And now we can set position X to 0 and position Y to 100. There we are. So this is where our level 1 now is. And I want to change its color to being white. I prefer that. And then I also would like to have a little shadow there. So I add a component called shadow. And once I'm done there, you can see now we have this little shadow in there. So this is basically how you can add a little text on your screen. And it's not inside of your scene directly. So you would have to scroll all the way out in order to see it, because as you can see now, it creates this huge little window, this huge window, which is basically our overlay or our canvas, which is this text that you can see here. So level 1, for example. All right. Now that we have the canvas, I would like to change the background because I would like this to look as close as possible to the original. Now, in order to do that, we need to add a shader. So I'm going to create a new folder, which I'm going to call shader. And in that folder, I'm going to drag a gradient shader that we have created. So actually not the scenes, but a gradient. So in another project, well, you can just download the project and download the gradient from there, because I could, of course, go into gradients and into shaders pretty much. And this is the code. So if you want to go ahead and copy the code, you can also copy it from here. You can pause the video and then just copy the shader from here. It's basically a reduced standard shader. But what we now can do is we can change the background of our game. So I'm going to create a new plane, 3D object, plane. I'm going to call this one background. And I position that at 0, -0.50. So you can see this is this white background that we have here. And I scale it up. So I'm just going to scale it that it's huge. So 50-50 should be good enough for our background. And 50 for the Z coordinate. So, well, in the Y coordinate, one should be fine as well. Okay, so 50 for X and 50 for Z. And now we have a background material. So I need to create another material. So let's go to materials. And here I'm going to go ahead and create a new material. And this one will be background level 1. And here I want to change it to custom and gradient. So here I have used my own shader. So the shader is called gradient. And in there, I just assigned 2 variables that I wanted to be able to change. So the top color and the bottom color. Now the top color, I want to use this value here. So 9CFF00. And the bottom color, I want to use FFFE00. And now we just need to assign this to our background. So let's go to our assets, materials, and background, shader to background. And now you can see we have this gradient here, going from this greenish color to this yellowish color. So this looks a lot more like the original. And this is actually pretty nice. So what you can now do is you can copy and paste or duplicate your background color, and you can rename it. So this one will be background color level 2 or level 2. You can also write it like that. And now you can, of course, change the value. So you can make it something like this reddish color, and it will look pretty cool already. So you can just play around with the values and you can create whatever gradient you want. All right, so now we can save our level. So now we have saved level 1. And by the way, if we look at our prefabs, I haven't dragged the ball in there, so I could rename this one to ball prefab, and I'm gonna drag this ball prefab in there as well. So I'm saving the screen or the scene again. And now what you can do is you can go to scenes and duplicate your level 1 scene and just double click and go to level 2. So now we're in level 2. You can see that here at the top, level 2.unity. And in order to make sure that I always know that I'm in level 2, I'm just going to change the name to level 2 here. And I'm going to assign my background material to the background. So now you can see this is the new gradient that I have here. So the new background that I have. And if I run this level, you can see it's basically the same thing. But now what we will need to do is to change the level, or change the actual design of the level. So let's do that. So in order to do so, we're going to need some minor changes. Let's go to the scene, and I'm trying to find a good position here. So like this should be good. So what I need to do is I need to get rid of this element, and I'm gonna drag that element over there. Then copy paste. Actually, let's delete those and drag this copied element in there. Now I'm going to get rid of this element here. So I'm just dragging and dropping stuff around, so you can just follow along. Just make sure that your obstacles are not on top of a ground piece, because if you have that, then your program, well, with your game will not work in the way that it does in my case. Okay, so I'm just rebuilding basically this other level that they have. So there we are. Now in the center, this one can be moved. Copy paste, and here move over. Then I don't need those ones here. All right, and then, well, basically what we also need to change is the whole positioning. Okay, so let's go ahead and drag this thing a little further to the bottom, because we will need to have some more ground tiles actually. So you can see we need to move them around. So if this is boring to you, of course, you can just skip to the next part. So you can just move forward in the video. So I'm dragging this one here, duplicate that one over there. Then I need a hole here and there. Okay, so this one goes here, that one up, that one goes there, and then I need to finally close the gap here. All right, and now I just need to duplicate the gaps or the grounds. That's it. Okay, so this is basically, I think, another level in the game. Actually, this one is in the wrong direction. So, okay, now we can test this level, and therefore I'm just going to move my ball towards the bottom, and let's just see if this level works as well. Now I need to finish it. And there we are. So this was an easy level, but in terms of building it, it was a little more difficult. And now you already see where the actual challenge is making this game. It's to create levels that work and create levels that are fun. So this is really going to be the part that you need to do, where you need to show all of your creativity. And I'm super excited to share or to get your levels that you can share with us. So if you create cool levels, please share them with us. But of course, be careful that you don't just copy the levels from the original game. You need to create your own levels. And I'm just using the ones for re-recognition or that you recognize the game directly. I'm not publishing this game this way, so if you want to publish the game, of course, use your own level designs, but you can use the code. So the code is available for you for your own usage. Now you might wonder, how the heck do I get from level 1 to level 2? Well, of course, I'm not leaving you alone here. I thought that that would be another great little extra feature, and I talked to my colleague and he said it wouldn't that be necessary, but he then luckily helped me out with this. So now we can go ahead to our game manager, because that's where we need to add some minor code in order to being able to load a new level. So it's like 30 or 40 lines of code. I'm going to explain everything that I'm doing here. So we need to take care of our game manager just having one instance. And that's something that I talked about earlier on, but I haven't implemented the code yet for it. And that is to create or use the awake method. Okay, so I implemented this awake method, which is called just before the start method. So we had the start method, we've seen it. It's called as soon as the object is fully created, so to speak. And the awake method is called a little earlier. So what we're checking is if the singleton is not equal null, then create, or this object that we're currently at is going to be our singleton. So this instance of the game manager is going to be our singleton. But if the singleton is not this object that we're currently running this code from, then please go ahead, destroy this game object, because we already have a game manager which is running. But please don't destroy this object on load. So that's basically what we're saying with our awake method. So next we need a private void on level was, or level finished loading, level finished loading. So that's how I'm going to call this method. Basically it needs a scene and it needs the load scene mode. So what we're just saying here is once we are done with one level, we want to create the next level, or want to load the next level. So on a level finished loading, we want to set up a new level. So we just call this method set up new level, which we have created here. We'll just say, okay, set all the ground pieces. All right. So now what we can do is we can implement the onEnable method, which means as soon as the game manager is enabled, I want to set a event. So I want to make sure that an event is active, and that one will be scene manager dot scene loaded. So there is a event. You can see it's this lightning symbol here. This signals that we're talking about an event here. So we're assigning an event, and we just say, okay, here plus equal on level finished loading. So this method here. What we're doing with this is we just say that each time a new scene is loaded, please call this method called on level finished loading, and hereby just load the next scene. And how do we load the next scene correctly or get the next level? Well, first of all, we need to check if our game is completed. So if we have colored all the ground tiles, so here we're just saying public void check complete. So this method will take care of that, and it will, from the beginning, it will just say finished is true. So is finished means this level is finished. We're just assuming it's true until we are proven wrong. This way is easier than the other way around. I tested it, because the other way around we need a whole code surrounding it, and this way it's super dense and we can really get to the point very quickly. So we have this for loop where we just go through all of the ground pieces in our game. So for I equals 0, I less than all ground pieces dot length. So we just say go through all of the ground pieces that we have and run the following code. We compare if all ground pieces at the position I is colored, is set to true, or actually is set to false. So here we say, if any of our ground pieces is not yet colored. So if this statement here is true, this means that at least one of our ground pieces is not colored, which then means that our game is not over yet. So we can just say is finished is equal false, and we can break out of our for loop. Okay, so that's what we're doing here. And then we can just double check, or we can just check if is finished. If at this point it's still going, so we're still inside of this check complete method, then run the next level. So call the next level method, and here next level. So we need to implement this method real quick. It's a very short one. Private void next level, and here we just say that the scene manager should load a new scene. So this load scene method is basically the method that actually loads the scene. Okay, this whole stuff that we did before with on level finished and set up new level and scene manager scene loaded and so forth, this is just the preparation to make sure that we make it as simple as possible in terms of code. Okay, so load scene, and here we just say scene manager dot get active scene dot build index +1. So what does that mean? Well, that means that if we finish the level, we want to call this next level method, and this next level method will check in which scene are we right now, and then just go to the next scene. So build index +1 means go to the next scene. And what does that mean in terms of Unity? Well, let's have a look. If we go to File, and here we go to Build Settings, we can see that we had scenes level 1 in our build settings. Now currently I'm in level 2. You can see that here at the top left corner, level 2 Unity. So if I add the current scene to it, you can see now I'm in level 2. At the same time, here at the right hand side there are numbers. So this number 0 means that we're in build index 0. So our level 1 equals to build index 0. Our level 2 equals to build index 1. If we had a level 3 here, it would equal to build index 2. So what we're just saying is, if you are in level 1, then just go to level 2. If you're in level 2, just go to level 3. Or other way to say it, if you're in build index 0, go to build index 1. If you're in build index 1, go to build index 2. So this is basically the code that we have here. We'll just say, okay, add buildx or add 1 to build index and then load that new scene. Because otherwise what we just could have added here is just load scene 0, which means go to level 1, or load scene 1, which means go to level 2. Okay, but by adding this little piece of code, we just say, okay, go to the next available level. But then, of course, this way, we're not taking care of that there is no level anymore. So if you're at level 2, you will not be able to load level 3. It will just reload level 2, or it will just create an error or something like that. Okay, so here you could build something around it where you or have at least 50 levels. Then if somebody reaches level 50, then you could add some minor code which double checks if, so let's say if something like get active scene build index is equal to 50. So if you have 50 levels, then go back to level 1. So something like scene manager load scene 0. So it will go back to build index 0. Or if you're not at this highest level, then just add another level to it. Now in our case, we can just say if build index is at 1, then just go to build index 0. So in this case, we would just go to our first level. Okay. All right. So this is going to be fine. Now we can go ahead and test our game and see how good we are. So let's run this. And actually, yeah, we can also run this. So let's finish this level real quick. This is the easiest one. And we can see that it's not called yet. So we're not moving over to the other method. So I have something missing still. And that is, of course, in the ground pieces, we need to add one more method. So each time that we change the color, we need to add this call here. We call this method called check complete, because in the game manager, we just created this complete or check complete method, but we're never actually calling this method. When we do call it is in our ground pieces, where we actually check, has the color changed, or each time that we change the color, we also check if we have finished the level. So if all of the ground pieces have changed their color. Okay, once we have this code, we can go ahead and run it. So let's run the code. And I like this level because it's super easy. It's very obvious what you need to do. So there we are back at level 1. Now let's see if we go back to level 2 once we have done this level. So actually, how do I get to this point? There we are. Okay, so there we are. Now you can see you're moving around between levels and things are working out perfectly. So now you could go ahead and use the system to create as many levels as you want. And yeah, just create a complete game. All right, so at this point, you need to install Android Studio. So you need to go to developer.android.com/studio/install if you want to run it on an Android device. So download and install Android Studio, and then you have the Android SDK automatically installed, or at least that should be the case. So if that's not the case, then you need to specifically install Android SDK. And once that is done, you can go back to Unity. You go to your build settings, you go to player settings, and the only thing that you need to change is the company name and the package name. So change the company name to whatever your name is, or whatever the company name is. In my case, it could be something like Dennis Panuta. And then the product name will be the name of the game. And then here at the bottom, you see something called package name. There you need to change the whole thing here. It should be com, for example, dot, then your company name, dot, your product name. So in my case, it could be something like Dennis Panuta, dot, and then it would be here. What else did I say? Roller Splat. Roller Splat. Okay. So once that is done, you can click build and run. Therefore, you need to have Android Studio installed, and you need to connect your Android device with it. So with your PC. And once you then build and run, it should run on your Android device. So you should be able to see how the APK is being installed on your Android device. If that's not the case, then you can at least get the APK built, and then you can take that APK file and load it onto your Android device in order to install it there. And then you can install it on your Android device and basically play the game. So that's it. I hope you enjoyed this video. I hope you liked it. If you did, then please leave a like. And of course, don't forget to subscribe. And thanks a lot for joining me on this journey. So I hope to see you in another video. And of course, also possibly my courses. So see you there.
Lions roaring in the morning sun, searching for a longer day. People feeling like the light has just come. We must never stop the way.